Okay guys, so today we're going to solve the problem nth node from the end of a linked list. So the question says, given a linked list of consisting of L nodes and a given number n, the task is to find the nth node from the end of the linked list. Okay, so what the question is saying that we're given a linked list such as this, and we need to find the second last. So n is the number from which we'll have to find. So if n is 2, we'll have to find the second last, node in the linked list. So if n is 2, then the output will be 8 over here. And if n would have been 4, then output would have been 6. Okay. And we have to solve this in overfin time and auxiliary space of 1. So the first approach, what comes to my mind, is we could just reverse the linked list, and we can then just iterate through it and find the second node from the in the linked list. Such as if we reverse this, it will have become 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then if we just iterate through the head of the linked list, so this would have become 9. So this will, when we just iterate through, we can keep a counter, and we can just check if the counter is equal to n. Then we'll just return the head. Okay. So let's code this out. So first, let's create a reverse function. Reverse head, if not head, return. Okay, now first is equal to head, second head dot next, first dot next is equal to none. And okay, so now while second third is equal to second dot next, then second dot next is equal to first, first is equal to second, and second is equal to third. Okay, and we'll just return first over here. So this is the portion for reversing the linked list. And okay, now this function is done. Now what we'll do is just create head equal to reverse of head. Okay, now till this step over here, now what we'll get in our code is something like this: 9, 8, 7, then 6, then 5, then 4, then 3, then 2, then 1. Okay, so this is basically what you get after this step. Okay, now what we need to do is just create a count over here which is equal to, let's say, 1, because we won't need to go from 0 for no reason. We just create a count equal to 1, and then while head, we'll just check if count is equal to n. We'll return a head dot data. Else we'll just do a head dot next. Head is equal to head dot next, and count is equal to count plus equal to 1. And if it's not present, we'll just return a -1. Okay, so let's run this. Yeah, and submitting it. Okay, it's submitted. So I'll run through this code one more time. So this is our question. Okay, so the first step is reversing the linked list. So this is the portion where we reverse the linked list, and after reversing, we get this. Okay, now we initialize a counter equal to 1. Okay, now we'll loop through this linked list. Okay, and we'll check if count is equal to head. Now, since head is present, we'll check if count is equal to n. So count is 1 and n is 2. So we do a head dot next. So now the head is at 8. Okay, and the count plus equal to 1 will equal to 2. Now we check again if count is equal to n. So now n and count are the same. So we just return head dot data. Okay, and for condition like this, if we have 5 and okay, and 10, 5, 100, and 5, what we can do is we can just, after reversing the linked list, we can just check if, so one second, so what we'll get is 5, 100, 10 and 5. Okay, so now when the loop will so we'll just keep on looping through the linked list, and if it loops through completely, we'll get a -1, because we'll just get out of the loop, and in the end we'll just return a -1, because we can't find the fifth smallest in the linked list from the backside. This is it. Okay guys, so this is how you solve this problem, and if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.